Hello, the purpose of this video is to explain how a roof is framed and how a structure is formed and drawn on plans for a complete set of building plans. So we are now on roof framing of our structure, and as you are watching it right now, there is a video tutorial and lecture found on YouTube about this document, 1004 roof framing. So as you see here on the diagram I show on the screen, a structure, second story or two stories, would start from the foundation. It doesn't show it here, but foundation. And on the foundation, you would have your wood structure, because this is all about wood structure. And on your wood structure, you would have studs on the windows and doors. You would have headers, and then you would have your top plate. Um, some jurisdictions, like California, would require you to have two top plates, so you would have a double top plate. On that one would rest your joist, okay? And your joist would be covered by a rim closure or a rim joist. On top of that rim joist, you're going to have your floor, which are basically just sheetings of plywood. It doesn't show it here too. And then on the joist on plywood, you would have your second floor wall, and just like the first floor, they will be spaced according to whatever the engineer would say. This one is 24 inches, and according to some jurisdictions, the maximum is 16 inches. The minimum, yeah, the maximum is 16 inches. In this case, it's 24 inches in some jurisdictions, but I think California, the maximum is 16. You would still have your header, and then on top of your header, and top of the stud, you would have again your plate, double plate or single plate. And on top of your double plate, you will have your truss. And on top of your truss, you would put plywood and then your roofing system. So this would be the part of your roofing system. This is your roofing framing, and it is formed by a truss. Okay. There are different kinds of trusses you hear in my diagram. There are trusses that are naturally pitched so that when the rain comes down, it will naturally go down as gravity goes down. Okay, but there are trusses that are flat. Okay, and on buildings, we usually use a flat truss or a sloping truss. Like this one, this is a sloping truss, but it looks like a flat truss, but it's just at an angle. So you can also do it that way. Or you would have a flat bottom, and this is called the how configuration, and the sloping top. This one is basically parallel, okay, parallel how configuration, and you make it parallel because the angle is naturally sloped. Or you can have two kinds of truss systems, and this is a little bit complicated. Sometimes it's used for very long spans. So we normally just use a flat truss system. It could be a Pratt configuration where you have a queen post like this one, and then it's just a mirror of the left and the right side. Or you can have this kind of configuration that's called a Warren configuration. Okay, so the engineer would have to decide based on the architect's also design whether they wanted a pitched design, okay, or a flat truss. And if you're using a flat truss, then you would have to find a manufacturer that does that. The engineer will design that, or will find a ready-made truss system that has been tested for weight, and then he would just assign or use that configuration. Okay, so here's a PDF file. If you click on this one and click on that, it would open for you a PDF file. It's just a bigger drawing, and it shows us what are the different kinds of truss that manufacturer can make. Basically, a manufacturer can create anything that you give them, but they would have a ready-made truss system that would be cheaper because it's not custom made. It's just their standard one. And usually it would be like a common truss like this one, or a flat truss that looks like this one. Okay, so those are the different things that we could do. So for our project, we will use a flat truss configuration. And when you have a flat truss configuration, you would have a problem with rain because the rain will not go down to the ground if you don't have a slope. So a flat truss system, although it's not efficient with rain, it's often used for buildings. And then the architect would have to solve how to get the rain out of the roof, and that's what we're going to do in a few more weeks' time. But today we're going to um, discuss how do we make the framing system for the roof. Okay, so here is a a truss manufacturer, Cascade, and they have ready-made truss, and on their truss they have the strengths tested. You have a total load of 40. On our second floor, if you remember, our load is 100 psf, and this one's 40 because on the roof there's really no one that walks over there except during construction, and maybe one person who would look at any leaks or whatever. So there's really not a much of load. Your load will be coming from snow or from rain. So in California, in some areas, they would specify how much load should the roof have minimum. Okay, so you might get away with a 40 total PSF, but in some higher elevations in California, they might require a higher PSF because they get snow on top of it. Okay, also the span would depend on I mean the width or the height of this truss, okay, or the depth of this truss would be dependent on the span and the load. So we could get away with 20 inch of rain and no snow with a 40 feet span, 41 feet. I want to put an extra there, and we could get out with a 32 inch. If you wanted a 41 span, but you anticipate snow, right? Then you would have to go down to a 36 inch, and then 30 inch snow 41, and then there's no 41 here but 42. They tested the span at 42, that's why there's no 41. 40 pounds square inch of snow, 1.15 duration per hour, that, and a load factor, the load of 55 pounds per square foot, and that means that your depth of this flat truss will be 48. Okay, now remember that this is also tested at 24 inches on center. Okay, you if you put your truss closer than 24, then it would actually accommodate a stronger load. So yeah, the maximum is 24 if you want to have this kind of strength tested. So also, the manufacturer has suggested that the most economical flat truss system is if the depth of the truss is just 70% of the span. So if you have a 40-foot span, which is in our case, our site is 40 feet wide, 7% of that one would be 33.6 inches. Okay, so that means that if you wanted the most economical one, you wanted to go to not more than 33. Okay, and that would be 32. That and 32 could only accommodate 40 pounds per square foot. Okay, and let's say the engineer would specify uh, a 36 inch deep. Only the engineer can really tell us the most efficient size of the truss for a building because he would have to do some calculations. Okay, or she would have to do some calculations. So we can calculate that one. Unfortunately, I'm not an engineer. I am an architect. Okay, but we often do structural work if for simple projects. Okay, so for our project, we will do a 36-inch deep truss, and make sure that you watch this video uh, to know how to do that roof framing plan. Okay. Okay, so let's go to AutoCAD, and we are going to create a new sheet. We can't fit the framing plan here because we have a lot of notes here. Okay, so we're going to fit the framing plan. And if you look at S2, we have our details over here. Okay, so um, what we can do is we can squeeze in a sheet here and move everything here as S3. Okay, so we're going to label this, change this to S3, and we're going to go back to S1, and everything that we said was S2 will now have to be changed to S3. Okay, so that's the hard part of squeezing a sheet in between the sheets already. Okay, so but we want to go through this this system so that I can show you how to squeeze a sheet. So you must take care of whatever reference is S2. It is now S3, so you have to take care of that one. And then we have to also change the name of this one to S3, S-3. Okay, enter. And then we go back to S1 and we're going to duplicate this. So we're going to have to do a right click, and then we're going to have to move or copy, check the create copy, and move this before S3. Okay, and click OK. And there you have your S1-2, and we're going to rename that to S-2. Okay, so make sure that you click on S2 before you do any changes, okay? Because S1 is already set. I'm not going to do that. So go to S2, and we're going to move all these drawings. Make sure it's S2 onto the left. And what we're going to do is we're going to copy this whole thing. So we're going to copy the second floor, the grids. We're going to copy the grids and the viewport. And copy. You can also do move because you're not going to use this anymore. And we're going to copy the title, and we are going to copy that here on the right side, and we are going to move also these notes. So we're going to move these notes. You know what? Let's not move the notes. We're just going to modify them later. Okay. And what you're going to do now, if you're going to make a copy, this is for the second floor framing. So you need the roof framing. So what you're going to do is you're going to go to the model space, okay, and you are going to copy this whole thing. So we're going to do a copy, and you're going to copy it somewhere here. Maybe you want, if you want it as far as that one, then go ahead. You're just going to make a copy. Oop, let's repeat our copy, okay? So we're just going to copy, and we're going to copy this whole thing, and we're going to move it here. Make the copy there. And we're going to remove all these frames because we won't need them. Okay. Well, before we do that, let's just do it in S2 so we're not. So how do we now go to the view of the roof framing? We click on the viewport, and we glide that on the side here until you see this. Okay. Once you have that, then you push back the other corner of the viewport, and then you simply bring this viewport by moving the viewport and holding it on one of the grids here. Okay, so Control F3. So Control, not this one. Close that. I was trying to do a Control F3 so I can do an Oxbow snap. So move this whole thing, and then we're going to hold it there, and we're going to put that back here. So we're going to do a perpendicular and back this corner here. There you go. Okay, so you're back there, and just adjust this viewport so we don't see any extraneous things. All right, so now you can see I deleted this because it's this part of the viewport. Okay, so we can delete again all of these over here, and when you go back to S2, you see that all this is deleted. So it's much safer to do this and keep your S. So if you inspect S1, S1 should not be affected by it because S1 is pointing to a different copy of the floor plan. S1 is pointing to this, was S2 is pointing to this. Okay, so much safer to do this in S2 so you won't make any mistake. We're going to delete that. We're going to delete this. We're going to leave this one because this one extends up to the roof. We're going to delete this. We're going to delete this. We don't need this too. We don't need any shear walls here. We don't need this portion of the elevator shaft won't exist in the roof. Okay, This one, there's no opening on the roof. We will see the outline of the second floor, but that's basically it. This one's part of the roof system, so we're going to do that. Okay, and we're going to call this the double click outside, and we're going to call this basically. We don't need two lines there. We're going to add here roof framing plan, and we're going to erase the top line. Okay, and we're going to call this number one again. Oh, okay, why is it number three? Let's go back to S1. This one's supposed to be two because there's only two drawings here, one and two, and this one's one. There you go. So save that. Make sure you save. Okay, we'll go back to S2. That's one. That's S2. And we can now begin our framing. Let us make a new layer called S roof frame. And then the color is also yellow. We're not going to change that. Okay. So once you have that, you can now choose S roof frame. We're going to close this. And we are now ready to do the roof. Okay. So first, because the roof, my design of the roof is flat, that means the walls will cover the roof. And so that means if the walls are covering the roof, I will actually draw a wall here. So I'm going to do a P line, and we're going to start here and then go here. And just go around onto, there you go. And then we're just going to use the offset, and we're going to use the same thickness. I think it's what, 7 inches? Oh, the offset, and then we're going to use the T option, the through option. Press enter, click here, and so I can click on an endpoint or nearest. There you go. So we just need a double line for all the roof. Okay. Um, and later on, we are going to cut a detail of this one for architectural. Okay. Anyway, that's going to be part of the top of the roof. There are no headers. We already have the headers on the second floor because there's no headers in this roof system. So all we're going to do is we're going to add the framings here. And we just talked about the uh, framing, right? The framing, we're going to use a 36-inch deep flat roof. We can space at 24, but as I have showed you this one, you want to space the roof framing as you space the stud. So if the stud is 24, then you want to space it at 24 inches too. Okay. Although it really doesn't matter structurally wise, it's just more safe because then the roof is being transferred to the load of the studs directly rather than to the plates. Okay. So our studs are spaced at 16 inches. So what we're going to do is we're going to also space our roof framing also at 16 inches. So we're going to do a double click because we're going to do it inside. We're going to do a P line, and we are going to just do a P line holding it back from those walls. Okay, you can actually move this over the wall. Um, maybe we should just do that, but I don't want to have a conflict, so we just hold it back because we're going to cut a detail anyway. So we're just going to click this and change the global width of this one to again 2 inches. Okay, and if you want, you can even click and change that to 3. Doesn't matter. It's just representation. Okay, and you wanted to array this again. Okay, up to here. So we're going to do an array, and we're going to click this, enter. We're going to do a rectangular array. Okay, and then we're going to do the spacing and the spacing. unit cell, specify the distance between columns. We don't want any columns, so we're going to just press enter. And then when the distance between rows, this is where we want to put 16 inch, press enter. And then all we're going to do is we're going to click this and then drag it up. And then you see that there's an extra one here, so click that. When it's gone, you simply click on the array and you can pull it back until you get to this one. There you go. Okay. Then you can simply just press enter to exit. And we are now going to make some adjustments. We're going to click this and then pull it back a little bit. Okay, so now you have like a double line there and you have like a double line here. So that's what we're trying to show, is we are doing some double line. Okay. Now, although this spans shorter, okay, we may switch to a different depth here. This one's all 36 inches, and we may switch to a different depth. And the problem with switching to a different depth is you would have to build the wall higher on this side, okay, which is fine. You can build the wall higher. So instead of a 36 inch, let's look at that one. Instead of a 36 inch, because we want to span that 41 feet, that actually, the span of that one is only 18. So if we go back to that one, 18 is going to be somewhere here, right? And the shortest one is 16. Okay, so it's gonna fall within 16 inches instead of 36. It's it's much cheaper. So we can build the wall higher. That's no problem because we're gonna save more money on the truss itself. Okay, so we're going to simply do a P line again, and we're going to simply attach from here all the way to here, and you won't see it because it's on top of the other. But so you're going to move enter, and then you're going to put L for last, enter, and then you're going to press enter again and click this and then drag it and then type in 16. Okay, 16. So that's a P line. We're going to match property. So match property, click this last one and point that one so it matches. Oh, it didn't because this is a block now. So click here and just change this to the global width of 3 inches, the one that we set it to. Okay. Um, if that's too thick for you, yeah, I think to me it's too thick for me. So simply, can I still change it? I can't now anymore. All right, so I just leave it like that. And then we're going to do another array. So array, two R's, just array. Click this, and then rectangular. And then we're going to do the spacing. The spacing is simply press enter, and the spacing is 16. And then, oh, we have two columns. Columns. We don't want two columns. We only want one. Enter. This might be two columns, so let's adjust it later. And then click this. Oh, what's happened? Click this, and then go here. Okay. And there's going to be one at this wall, but because it's a wall, we don't really need one. Okay. Let's. I think that this one has a extra column, so we're going to click here. There you go. So click this, and we're going to retreat it here, back here, and then go back to S2. There you go. We don't see that problem because it's outside anyway, so it doesn't matter. Yeah, so it's just like that. The roof framing is just that one, and you're basically going to say that all of these are 36 inches. Okay, so we are simply going to copy this one here. Now, where is it? Oh, it's here. Copy this. I'm going to copy it. I am in model space. I have to go to paper space before I copy. Copy this and point from here, and we're going to move it over here. And we're going to simply adjust that and point to this, and adjust that and point to this. And we're going to bring this line closer here. And we're going to bring this also here. And then we're going to say that this is a truss. We can always say flat truss, but we're going to do add notes later. So we're going to say truss at 16" on center. And we need to identify the depth of that truss. 36" deep. You can say deep. Okay, we can always say wood truss, or we can just say wood truss. Just say deep truss, or we and then we can just click that one, and we can bring that, click this, and move that closer. Okay, and we're going to do the same thing here. We're going to simply copy and copy this in this corner. We're going to move that to this corner here, or copy that from this corner, and then click this and change this and put that here, and click that and move that somewhere in the middle. And we're going to change this. We're going to say that this is 16" deep plus. Okay. Yeah. Um, so we have to actually put on section the height of this one, so we have to cut a section later. Um, but that's basically it. We're telling it in framing that it's the same thing. And then we're going to add notes here on the side. And I think that's it. That's basically structurally wise. We just want to space it out. Now you can also space it out 32 inches. Depends on the engineer. If 16 inches is spaced out, because you remember that this one is spaced at tested at 24. Okay, so if you want to space it out at 32, the engineer must calculate loads based on 32, not 24 inches. Okay, so we're gonna leave it at 16. Okay, to be on top, but either 16 or 32. Sometimes 48 is okay too, but it's not just on top of the studs. Okay, and our next step would be doing the notes for this framing. All right, so we're going to now create or modify these notes. And one of the things that we have to modify, the first thing, is the top of the truss. Where is it? Okay, so we're gonna put here a framing note. So we're gonna erase all of this, and we're going to erase all of this, and we're just gonna bring this one up like that. Okay. Uh, yeah, just we're not gonna standardize that, but yeah, some people would have a standard, or some firms have a standard how high this framing notes are. But we're gonna modify this to say roof framing notes, and the first thing that we're going to put here is the 36" backspace, and 36" deep truss will be uh, flat 36 um, flat truss. And then let's go to our identify this. So we're going to simply do a load, and we are doing a 40 PSF. Okay, 115. And we should also put here lumber properties like this one. Okay, so we're going to put total load is 40. load capacity 40 PSF. And then we are going to copy well, copy this one here. Uh, Lumber properties as follows: 2 by 4 FB. We're gonna do that. Um, Too bad this is a text. I wonder if let's see. Oh, there you go. So we're just going to simply, and how did I get to this one? This is through this one, this chart. So if you click that and you open it, it will open this PDF. And when it's open as PDF now, you can select that. You wanted 10 to the 6. Oh, it doesn't. Okay, 2 by 4, and we wanted 10 to the 6. But Control C, and let's see whether we can paste that in AutoCAD. Where's my drawing? Nope. There you go. PSF. And then we're going to paste that. There you go. And put a parentheses. And we wanted to the 6. So here we put in a 6 and put in a 6. We don't want number 2 there. PSI. Let's just press enter here. Backspace. Need to press shift, enter. And PSIE. Let's do the 10 to the 6 first. So click that. And then over here, we want a superscript. Highlight that one, 6. We want to also put a 6 here. So highlight that one and superscript. Okay. Well, so 2 by 4, F equals 2000. Let's review again the 2 by 4 FB is 2000 PSI. It didn't copy the FB. So we have to modify that again. 2000, 2 by 4 F, and then this one, we want to put B, small b, and we want to highlight, and we want to click here, underscript, or not underscript, but subscript. Okay, PSI, and then F dot PSI. What about the E? So E equals, so this one is an F1, so let's just do too small. Yeah, FT, so that's T. So FB, then PSI, FT, and what are these? These are properties of the lumber. And when this is based on calculation, and we want subscript PSI. E does not have a subscript E, but has superscript and 2 by 6 FB. 2 by 6 FB. 2 by 6 PSI. And just press enter until it goes down to that one. F, this is again a B, and that has the subscript PSI, and then the last one here, FB is 915, is FC. Okay, FC. So go here again and put in a small letter C and highlight that, and then change it to subscript PSI, and we have another E. We have another E. Yeah, 1.8 times 10. Okay, here we go. So we're gonna put that in and put a question mark. Then press number 2, and then we're going to do the same thing. We're going to put in 16-inch deep truss. Then we can copy the whole thing because they're basically the same. They have the same property. Okay, so then press enter here and backspace to create a note, and then press enter, and top of, see, top of truss, unless you O N. So what this means is unless otherwise noted. You can spell it out, but you can also acronym it. As long as you have a legend for what UON means. Typically, everybody knows in construction what UON, unless otherwise noted. Top of truss shall be at, we have to open up our elevation section. Well, let's look at that one. So just select one and open up your preliminary elevation and look at your top of your roof is 28 feet. Okay. Now there is some issue here because we only have allocated at um, a specific depth here, and I think that's only 24 inches. So it would either be that we need to raise this up um, or lower the roof here. Okay, raising the building up will certainly be more expensive, so we have to decide on that one later. But this section will have to be modified according to what the structural says, and that means that this window will be affected as well. Okay, so it's either we raise this later or not. But I'm more inclined to just leave it at 28 feet. So we're going to go back here and we will say top of truss unless otherwise noted shall be 28 0 inch above A F AFF, okay, above finished floor. You put up from datum 0 feet 0 inch, parentheses. Okay, oh, I need to put a space there and then backspace. All right, okay, and basically that is it. We have to just cut sections later on how the connections will be, and uh, we have to add that connection per according to the manufacturer. Okay, so we're gonna put here. Oh, press 4. Connect press to top plates of wall per MFR manufacturer standards. Okay, and then we are going to put in C specifications. So that means that there would be a book specifications. There would be a book accompanying this one, and that would be called structural specifications, and that would have that one. Connect truss to top plate of wall per manufacturer standards. C specifications. There you go. And that is your S2. And the next thing that we're going to do is we're going to do um, details of this one, but I think we're going to do that on our next module, and this will be the last part of your assignment for this week's module. Okay,